In this topic, we are going to discuss the IP phone boot up process, and this has quite a few steps that are involved to get the phone from a completely off state all the way through to fully functional and being able to make telephone calls and receive calls and the likes thereof. The very first thing that we need to be looking at here is step one, and step one comprises of being able to give power to the telephones to be able to boot up and obviously turn on. Now, the power can be derived or given to the telephones in a few different ways. The one option is, of course, to use PoE, which allows us to use power over Ethernet through a switch. So if the switch that we happen to have over here did support power over Ethernet, it would be able to deliver the power to the telephone based on whatever the voltage requirements were, whatever the watt requirements were. And of course, within PoE, we have multiple different standards of PoE that exist for delivering different amounts of power and on which wires we use. So what's important to understand here with PoE is really this breaks down into, if you will, two more subsections. The one subsection we find with PoE is what we used to refer to as inline power, and the second one here would be known as external power. Now, these are not the official technical terms. The inline power really was about the idea of delivering power down the same wires that the data was being sent down. So this would have been pins 1, 2, 3, and 6. Whereas external power was not about plugging it into a wall socket. External power was about using the pins that were not used by data. So this would typically be pins 4, 5, 7, and 8. Now this changed sometime over the years where we started using all 8 pins for data communication, and what we found was historically the external power would have been done through things such as mid-span injectors. So rather than using the actual switch over here to deliver the power, we'll find that very often, in fact almost always, a telephone will never be plugged straight into a switch. It will usually have another device in between here known as the patch panel. And that patch panel very often could be used to deliver that PoE to the actual end devices. And this would be known as a mid-span injector. So within PoE, although we've got different standards of PoE, so we have PoE, we've got PoE Plus, we've got PoE AT, and the standards keep on evolving, these all are about how it delivers the power down the certain wires, but also how much power is capable of being delivered to the end devices. The other option for the power delivery, if we walk away from PoE entirely, is to use a power cube. And this really is a case of plugging in the AC adapter into the back of the phone and plugging it into a wall socket. And that way it gets power directly from the power supply. So this is the very first phase. Step 2. Once the telephone has got power and it's starting its boot cycle, the very next thing for it to do is then go and load whatever image it has locally stored on it. Now, if this is a brand new phone, this would be a default image. If this is a phone that's been inside your organization for some time, hopefully it would be the same image that the CUCM is running and the same versions. So, and it's important to understand that concept here, as we'll see in the next few steps. So first of all, in step 2, we load whatever locally stored image we have, and this is what's known as the phone load. Step 3, we then want to identify what the voice VLAN is by doing a query either via CDP or using something like LLDP. We should then hopefully get a reply from our switch telling us what the voice VLAN is that we need to place the calls into. And of course, we could also then discover what the data VLAN is by non-tagging that information. So what that means is that anything that needs to come from the actual cradle from this handset would be tagged with the voice VLAN. If there was a PC plugged into the back of this telephone, it would not be tagged. So in theory, placing that into the native VLAN. And that could then obviously be identified on this port over here as to if it's tagged, it's voice. If it's not tagged, it's data. So, and of course, if it's tagged, we can read which tag to place it into the correct voice VLAN. Now, step 5 through 6, 5, we need to get ourselves IP address settings. And it's not so much just IP, there's quite a few things here. We need to look at getting ourselves an IP address, subnet mask, a default gateway, DNS settings. DNS, by the way, would be the server's IP address, as well as what domain name I need to belong to, and then that all-important option 150. Option 150 gives me the IP address of the TFTP server, which makes sense then why step 6 is for us to go and connect to that TFTP server to download my first piece of my configuration. Now that first piece of configuration that I'm going to retrieve from that TFTP server is going to contain a few very valuable pieces of information. One, what version of the software should I have? So the important thing for me to identify from that config file is what version is physically running on that telephone. Does it match what the configuration file says? Notice how I'm not asking whether it's newer or older, it's about whether it matches. So we always have to be on the same version as whatever the CUCM is running. So if that requires me to downgrade the software, that's what would take place. So of course the most important thing here is that if the version doesn't match, that's when I would then download the phone version from the TFTP server. So the TFTP server would be the server that I'd then be able to download that file to, and then by the way, the whole process would start again. So it would have to reboot, and it would have to load that new firm image, and so it would carry on. Now let's assume that that process is either finished or it didn't need to take place because the versions did match. Well, then step 8 is for registration to take place. Registration, part of that configuration file, will contain who my primary server is, my secondary server, and who my tertiary, if one has been configured. So I immediately know, hey, this is my first server I need to go and register with, and if that was unsuccessful for whatever reason, I would then try and connect to the secondary, and of course the tertiary if needed as well. It's at that moment that the rest of the boot sequence would complete by us downloading the remainder of our configuration, and that configuration would come from our CUCM.